Okay, ladies and gentlemen, now it's time to take a look at the combined gas law. All right. So along the way, we learned that as temperature goes up, pressure goes up. We also learned that if you have a balloon or something that will expand as temperature goes up, volume goes up. And then we also learned that as volume goes up, pressure goes down. And so when those things are put together into a single equation, they end up like that. And so when moving forward, I am going to use blue to stand for the initial state of things, and I'm going to use yellow to stand for the final state of things. And we're going to use a problem-solving method called GUESS, where you have the givens and the unknowns. You write your equation, you substitute, and then you solve. Now, the final thing that you have to remember about gas laws is you have to use what's called the Kelvin temperature. All right? And so 0 degrees Celsius, which is where water freezes, in Kelvin is 273. So you can see here 0 is 273. Boiling is 100 degrees Celsius, that's 373. So to get Kelvin, you need to add 273 to Celsius. And we use Kelvin because 0 degrees Kelvin is where all molecular and atomic motion ceases. It's absolute zero. That's negative 273 Celsius. All right, so everything has to be in Kelvin. All right, well, without further ado, let's do our two examples. The volume of a gas is 22.5 milliliters at 22 degrees Celsius and 0.97 atmospheres. All right, so that is all of your initial stuff. So in the given and unknown, you need to keep track of the initial pressure, the initial volume, and the initial temperature. So the initial pressure is 0.97 atmospheres. The initial volume is 22.5 milliliters. And the initial temperature is 22.0 degrees Celsius. But you need to add 273. So it's actually 295 Kelvin. All right. So those are my initial values. All right. So we continue to read the problem. What will be the what will the volume be at 15 degrees Celsius and 0.99 atmospheres? You're supposed to report to one decimal place. All right. So PF for final, VF for final, TF for final. Some of those will be given, one will be your unknown. What will the volume be? Well, there's my unknown. The thing to remember here is that your volume is always going to be in the same units as it was given, okay? So it's going to be milliliters in the end. At 15 degrees Celsius, well, it's 15 degrees Celsius, right? But we have to have it in Kelvin. So you're going to need to add to that, and that's going to be 288 K. And 0.99 atmospheres. So slightly more pressure, but not much. All right, so that is our final. All right, so there we are. Next, we're going to put our equation in there. That's what E stands for. So the equation is PI times VI over TI is equal to PF times VF over TF. S is substitute. You're just taking the things that you know from here and putting them into the equation there. So PI is 0.97 atmospheres. VI is 22.5 milliliters. TI is 295 Kelvin. Is equal to PF, 0.99 atmospheres, times VF, that is the thing that we do not know, over 288 K. All right? So now we're going to take all of this and we're going to multiply it together. I'm going to go parentheses 0.97 times 22.5, close parentheses, divided by 295K. And when I do that, I'm going to get 0.07429. I'm not going to worry about rounding yet. Then I'm going to take 0.99 and divide it by 288. And when I do that, I'm going to get 0.00344 times VF. All right, now, algebra tells us that if I want to know what this is, I need to get rid of that. The way that you get rid of that is I divide both sides by 0.00344. So I'm going to divide this by 0.00344, and those will cancel, of course, and leave me as 1. Then I'm going to divide that by 0.00344. And in the end, I'm going to have VF is equal to 0.07429 divided by 0.00344. I'm going to end up with this number, 21.5959. I want one decimal place, so it's going to be that one right there, right? The number behind it is greater than 5, so I'm going to round up to 21.6. It's a volume. What was my unit? It was milliliters. Now, another way that you can do the unit thing, of course, is just cancellation. So, no, I think I'm going to skip that. We're going to go with the units having identified them from the beginning. All right. Now, there you go. Next, the pressure in an automobile tire is 1.88 atmospheres at 298 K. All right, so PI, VI, TI. So the pressure is 1.88 atmospheres. Volume, we don't know. Okay, so we're going to leave that blank for the moment. You'll see why here in just a second. The temperature, 298 Kelvin, which is what we want it to be, because it has to be Kelvin, not Celsius. What will be the pressure? If the temperature warms up to 310. Report to 2 decimal places. All right, so PF we do not know. What will be the pressure? What unit is it going to be in? It's going to be in the same unit as the given. So it's going to be atmospheres because the given was atmospheres. Again, we don't have a volume. TF is 310K. Now, let's think about this whole volume thing for just a moment. They don't give you a volume, and the reason that they don't give you a volume, no V is given because volume is constant. The volume doesn't change, right? It's an automobile tire. The size of the tire is not changing, right? Whatever size tire you have on your car, that's just the size tire you have on your car. So that means that since they don't give it, we're simply not going to use it. And you'll see why right now. So PI VI over TI is equal to PF VF over TF. We're simply going to leave the volumes out because they do not change. Now we're going to substitute. PI is 1.88 atmospheres divided by TI, 298K, is equal to PF, which I don't know, that's my unknown, divided by 310K. Now, I'm going to take those numbers right there, and I'm going to go ahead and divide them and find out what they are, okay? So, 1.88 divided by 298 is equal to 0.0063087. Doesn't really matter. I'm going to keep several decimal places so I don't get rounding error. Is equal to PF divided by 310. Now, algebra tells us that in order to get rid of this, I have to multiply both sides by the same number, which is 310. So I'm going to do that now and drag this a little over to give myself some space. So I'm going to do that now. I'm going to multiply this side by 310. That's going to make those cancel out. Then I'm going to multiply this by 310. And when I do, I'm going to get 310 times 0.0063087. And I'm going to get 1.955697. It told me that I want 2 decimal places. So that is my second decimal place. The number behind it is a 5, so I'm going to round that up to 6. So my final answer is 1.96, and my unit is atmospheres. All right, so you need to do the next 4 for practice and check them in the answer checker to make sure that everything's okay. Good luck.